Hi all, myself Isacc, Chemistry Excel. See, today my aim is to convert the chapter Electrochemistry in a glance. Okay, I selected few questions from the previous, PYQs of Electrochemistry. I think you'll get something, right? Start. Regarding electrochemistry, what is meant by electrochemistry means electrochemistry is a branch of chemistry dealing with a conversion of electrical energy to chemical, or I can say chemical to electrical. Fine. Anyway, the entire chapter I'm dividing into three segments, right? Calling it as electrochemical cell, calling it as electrochemical cell, electrochemical cell, electrolytic cell and commercial cell. Okay, electrochemical cell, electrolytic cell and commercial cell. What is meant by electrochemical cell means electrochemical cell is a cell which converts chemical to electrical, whereas electrolytic means which will convert electrical to chemical, whereas commercial cell means, let's see about in detail. Okay, I think one question guaranteed for you is they will ask either anodic and cathodic reaction of any of the commercial cell. As you know, commercial cell is of two categories called as primary cell and secondary cell. Rechargeable one is called as secondary cell. Non-rechargeable is called as primary cell. This primary cell is of two, main examples are dry cell, mercury cell. Secondary cells includes lead storage cell, nickel cadmium cell, and there is one more called as H2O2 called as fuel cell, neither primary nor secondary. I'm guaranteeing you either anodic and cathodic reaction of dry cell, mercury cell, lead storage cell, nickel cadmium cell or fuel cell is an 100% guaranteed for you. You can refer. Okay, let's see one by one. Anyway, I'm starting from electrochemical cell, moving into electrolytic cell, will be wind up with commercial cell. Once again, electrochemical cell is a cell which converts chemical to electrical energy, whereas electrolytic cell is a cell which converts electrical to chemical, whereas the last part is called as commercial cell. Commercial cell is of two categories called as primary cell and secondary cell. Non-rechargeable one is primary, rechargeable one is secondary, whereas neither primary nor secondary is called as fuel cell. Primary cell includes dry cell, mercury cell. Secondary cell includes lead storage cell, nickel cadmium cell. Either they will ask anodic and cathodic of any out of these five. Hope you are fine, right? Moving into electrochemical cell right now. See guys, electrochemical cell, I already told you, electrochemical cell is a cell which converts chemical to electrical energy. Fine. Electrochemical cell may also called as galvanic cell, may also called as voltaic cell. The best example for a electrochemical cell is called as Daniel cell. Okay, the best example for an electrochemical cell is called as Daniel cell. Daniel cell is a zinc copper cell. Daniel cell is a zinc copper cell. Dealing with electrochemical cell. Electrochemical cell may also called as galvanic cell, may also called as voltaic cell. Best number one example for an electrochemical cell is Daniel cell. Daniel cell is a zinc copper cell. In that zinc copper cell, a setup is zinc dipped in zinc sulfate solution. Setup is zinc dipped in zinc sulfate solution. Similarly, copper dipped in copper sulfate solution. They will be connected by using a voltmeter and a salt bridge, right? So it's called as Daniel cell. Daniel cell is a zinc copper cell. Zinc dipped in zinc sulfate solution. Copper dipped in copper sulfate solution. They will be connected by using a salt bridge and a voltmeter. Will be connected by using a salt bridge and a voltmeter, right? Will be connected by using a salt bridge and a voltmeter, right? Hope you are fine, right? See here, zinc will be acting as the setup is zinc dipped in zinc sulfate solution. Copper dipped in copper sulfate solution will be connected by using a voltmeter and a salt bridge. Here zinc will be acting as anode. Here zinc will be acting as anode. Copper will be acting as cathode. Fine. So zinc copper cell, zinc dipped in zinc sulfate solution, copper dipped in copper sulfate solution connected by using a voltmeter and a salt bridge. Here zinc is acting as anode, fine, okay. Here zinc will be acting as anode, and anode is a place at which oxidation happen. Oxidation means removal of electron, right? Here zinc is acting as anode. Anode is a place at which oxidation happen. Oxidation means removal of electrons, so zinc will be removing 2 electron, becoming Zn2 plus, cool, right? Similarly, copper will be acting as cathode here. Similarly, copper will be acting as cathode. Cathode is a place at which reduction happens. Reduction means addition of electrons. So Cu2 plus will be adding 2 electron to become Cu. Cu2 plus will be adding 2 electron becoming Cu. While writing overall reaction, 2 electron get cancelled. Remaining will be Zn plus Cu2 plus giving Zn2 plus Cu, right? Hope the basics are fine for you, right? That's all my Daniell cell. So Daniell cell is a zinc copper cell, fine, cool. Zinc dipped in zinc sulfate solution, copper dipped in copper sulfate solution, connected by using a voltmeter and a salt bridge. Here zinc is acting as anode. Anode is a place at which oxidation happen. Oxidation means removal of electrons, so zinc will be removing 2 electron, becoming Zn2 plus. Similarly, I can say copper is acting as cathode. Cathode is a place at which reduction happen. Reduction means addition of electrons, so Cu2 plus will be adding 2 electron, becoming Cu. While writing overall reaction, 2 electron get cancelled. Remaining will be Zn plus Cu2 plus giving Zn2 plus Cu, fine, okay. See here zinc is acting as anode. Anode is a place at which oxidation happen. Oxidation means removal of electrons. I can say zinc is removing electron, right? But copper is acting as cathode. Cathode is a place at which reduction happen. Reduction means addition of electrons. So cathode is accepting electrons. I can say electron is moving from anode to cathode. Hope you are fine, right? Electron flow is from anode to cathode. If electron is flowing from anode to cathode, then definitely, as you know, the conventional direction of electric current is opposite to that of electron flow. If electron is moving from anode to cathode, I can say current will be moving from cathode to anode, okay? Current will be moving from cathode to anode. In order to flow the current, there should be difference in potential, and current will be flowing from higher potential to lower potential. Here in my question, in my Daniell cell, current is moving from cathode to anode, means I can say cathode will be higher potential called positive. Anode will be lower potential called negative, right? Here electrons are moving from anode to, okay, fine, cool, right? If electron is moving from anode to cathode, current will be from cathode to anode, and I know that current will be flowing from higher potential to lower. So if current is moving from cathode to anode, means I can say cathode will be higher potential called positive, anode will be lower potential called negative. Potential difference across this anode and cathode is called as cell potential. Potential difference across this anode and cathode is called as cell potential, which is represented by E cell. Cell potential, which is represented by E cell, and that E cell is given by the formula E cell equal to E cathode minus E anode, right? Hope you are fine with the basics now, right? Clear? See, one more thing over here. While writing the cell, while drawing the cell, we can write the cell in a single line representation, which is called as representation of an electrochemical cell. Initially, write the name of anode, put a bar, anode bar, anodic solution, double bar, cathodic solution bar, cathode. Instead, drawing the cell, we can write the cell in a one line called as representation of cell, anode bar, anodic solution, double bar, cathodic solution bar, cathode. Example, in case of Daniell cell, you can say zinc is the anode, right? In case of Daniell cell, zinc is the anode. Anode bar, anodic solution is ZnSO, or we can say simply ion called Zn2 plus. You can say simply ion called Zn2 plus. Double bar, cathodic solution is copper sulfate, simply the ion called Cu2 plus bar Cu, Cu2 plus bar Cu, right? So that's all regarding the basics of electrochemical cell. Electrochemical cell is a cell converting chemical to electrical. Electrochemical cell may also called as galvanic cell, voltaic cell. Number one example for an electrochemical cell is Daniel cell, right? The number one example for an electrochemical cell is Daniel cell. Daniel cell is a zinc copper cell, zinc dipped in zinc sulfate solution, copper dipped in copper sulfate solution, connected by using a voltmeter and a salt bridge. Zinc is acting as anode. Anode is a place at which oxidation happen. Oxidation means removal of electron. Copper is acting as cathode. Cathode is a place at which reduction happens. Reduction means addition of electrons. So I can say electron is moving from anode to cathode. If electron is moving from anode to cathode, then current will be from, because I know the conventional direction of electric current is opposite to that of electron flow. If electron is moving from anode to cathode, current will be from cathode to anode. In order to flow the current, there should be difference in potential called as cell potential, given by the formula E cell equal to E cathode minus E anode. Fine, cool. Well, representing a cell, anode bar, anodic solution, double bar, cathodic solution bar, cathode, right? In my Daniel cell, I can say zinc is anode, anodic solution will be ZnSO4, same as Zn2 plus, right? Double bar cathodic solution, CuSO4, cool, same as Cu2 plus bar Cu, right? One more thing for you, they will ask in usually in the board exam, right? What's the purpose of salt bridge in this Daniel cell? Salt bridge will be used for completing the electrical circuit or to maintain the electrical neutrality. 2.5 additionally for you. No, the purpose of salt bridge, or you can say functions of salt bridge. Salt bridge will be completing the electrical circuit. Salt bridge will be completing the electrical circuit or to maintain the electrical neutrality. Fine, right? One additional point for you, salt bridge. Salt bridge will be used for completing the electrical circuit, to complete the electrical circuit or to maintain the electrical neutrality, to maintain the electrical neutrality. One more point for you. I told you now, entire chapter we can divide into three segments: electrochemical cell, electrolytic cell, commercial cell. Fine. Electrochemical cell is a cell converting chemical. Fine. Electrolytic will be converting electrical chemical. Okay, but I can say that this electrochemical cell can be converted to electrolytic cell by applying an external potential greater than the cell potential of the electrochemical cell. Point for you. You can convert electrochemical cell into electrolytic cell by applying an external potential greater than the standard cell potential of electrochemical cell. Can I start the question, please? Point clear, right? So you can convert electrochemical cell into electrolytic cell by applying an external potential greater than the standard cell potential of electrochemical cell. Cool, right? Question number 1, please. Okay, sorry. Number 1. Which of the following is wrong about galvanic cell? Which of the following is wrong about galvanic cell? Anode is positive, wrong, right? See, I told you now, electrons are moving from anode to cathode. If electron is moving from anode to cathode, current will be moving from cathode to anode. In order to flow the current, there should be difference in potential, current flowing from higher potential to lower potential. That's why, since current is moving from cathode to anode, cathode will be higher potential called positive, anode will be lower potential negative. So anode positive is a wrong statement, right? That's enough. Cool. So you can say anode is positive is a wrong choice. Anode is a positive is a wrong choice. Let's check the remaining two, right? Oxidation occurs at the electrode with the lower reduction potential. That's correct, right? Because potential means tendency actually. Oxidation potential means tendency to undergo oxidation. Reduction potential means tendency to undergo reduction. For example, if you want to have high tendency for eating biryani, you will eat biryani, right? Imagine you have an high tendency to eat biryani, means eat biryani. That's the same thing. I can say, suppose if a metal is having high tendency to undergo oxidation, it will easily undergo oxidation. If a metal is having high tendency for reduction, they will easily undergo reduction. The tendency to undergo oxidation called as oxidation potential. Tendency to undergo reduction will be called as what, guys? Reduction potential. If oxidation potential is high, tendency to undergo oxidation is high, they will easily undergo oxidation. Same logic. Reduction potential is high means tendency to undergo reduction is high, so they will easily undergo reduction. If you have high tendency to biryani, eat biryani, right? Same thing. So I can say one more thing. So one more thing for you, right? If a metal is undergoing oxidation, the logic is if a metal is having high tendency to undergo oxidation, then tendency for reduction will be less. Either oxidation reduction, both will not happen, right? Either donate electron or accept, both no, right? Same logic. So I can say, see, question here given, the statement given, oxidation occurs at electrode with the lower reduction potential. If reduction potential is lower means they will not undergo reduction, they will undergo what? Oxidation, correct? Because reduction potential is low means tendency to undergo reduction is less. They will not undergo what reduction? They will undergo oxidation, cool, so it's okay. Then cathode is positive, yeah sure, cathode is positive, fine, cool, right? That's okay. Then reduction occurs at cathode, yeah I know, anode is a place at which oxidation happen, cathode is a place at which reduction happens, so it's okay, fine. The wrong one is option A where anode is positive, right? The wrong one or the correct option is option A, right? It is board, I guess. Question number 2. If a salt bridge is removed, then EMF of the cell. See, a function of a salt bridge is what? To complete the electrical circuit, right? The function of a salt bridge is to complete the electrical circuit or to maintain electrical neutrality, right? So if a salt bridge is removed, circuit is incomplete, current will not flow, there will not be having potential difference, or I can say potential drops to zero. See guys, function of a salt bridge is to complete the electrical circuit or to maintain the electrical neutrality. If a salt bridge is removed, circuit is incomplete, there is no current flow, there is no potential difference, or I can say potential drops to zero. Option A, please. It came in actually MCQ as well as in the word problem. You can check the previous, you can check our Excel course book, I guess. You can see, right? Drops to zero, or they came like same question comes in a descriptive way also. You can check. Now, question number 3. What happens when an external potential applied is greater than E0 cell of galvanic cell? I told you, galvanic cell, electrochemical cell can be converted to electrolytic cell by applying an external potential greater than the standard cell potential. So question ready. What happens when external potential applied is greater than the E0 cell, greater than the standard cell potential of galvanic means I can say it behaves like electrolytic cell. Option C, please. Option C, right? Fine. Question number 4, guys. A cliche question, right? You may know this one. It came in same NEET JEE pattern to write. Question: given that the standard electrode potential E0 of some metals are given, the correct order of reducing power. See guys, reducing power. Reducing power means, reducing agent means, reducing, all are same logic. Reducing power, reducing ability, reducing agent means undergoes oxidation. In order to undergo oxidation, oxidation potential should be high. Tendency to undergo oxidation called as oxidation potential should be high, or I can say reduction potential should be low. But as per the IUPAC convention, as per the IUPAC standard, always the given potential will be reduction potential. Question ready? I told you question, the correct increasing order of reducing power. Okay, let's see. The correct increasing order of reducing power. See, one more thing, reducing power, reducing agent, reducing ability, all are same. Reducing power, reducing ability, reducing it, all are same. Reducing power means, reducing agent means undergoes what, guys? Oxidation, right? Undergoes oxidation. In order to undergo oxidation, I can say oxidation potential should be high. I can say the oxidation potential called as tendency to undergo oxidation, that oxidation potential should be high. That oxidation potential should be high, or think in opposite way, reduction potential should be low. But as per the IUPAC standard, always the given reduction potential, given electrode potential is same as reduction potential. So I can say reduction potential should be low. Reduction potential should be low. Logic is fine, I guess. I can give a simple shortcut for you. See, I told you reducing power means reducing agent, reducing ability, all are same, cool, right? A reducing agent undergoes oxidation. In order to undergo oxidation, oxidation potential should be high, because a tendency to undergo oxidation is called as oxidation potential should be high, or I can say reduction potential should be low. But as per the IUPAC convention, the electrode potential given will be what? Reduction. Second shortcut for you. Reducing power is inversely proportional to, common logic only actually. Reducing power is inversely proportional to electrode potential, because electrode potential means what? Reduction potential. Reduction potential low means reducing power will be high, because reduction potential low means same as oxidation potential high. If oxidation potential is high, they will easily undergoes oxidation. The one which undergoes oxidation called as what? Reducing. And so cool, right? So again say reducing power is inversely proportional to electrode potential. Reducing power will be inversely proportional to electrode potential. So one having less electrode potential will be having high reducing power, right? The one having high electrode potential will be having least reducing power, or the one having less electrode potential will be having most, right? Least value please. Among the given option, minus 2.93 plus 0.80 minus 0.74, least value is minus 2.93. It's enough, right? Potassium is having least value, so potassium is having least electrode potential. Electrode potential least means I can say reducing power is most. Cool, right? Option potassium having minus 2.93, then chromium come minus 0.74, then yes, iron will come 0.44, then silver will come. Sure, option C please. Fine. Next one. Choose the correct answer. Choose the correct answer. The EMF of a Daniel cell at 298 Kelvin is E1. The EMF of a Daniel cell at 298 Kelvin is E1. When the Daniels, okay, wait. Question given Zn bar, ZnSO4 having 0.01 molar concentration. Copper sulfate is having, you know, Daniel cell, right? Anode bar, anodic solution, cool, right? 0.1 molar Cu. The concentration of ZnSO4 is 1 molar. Initially was 0.01, guys, right? Initially was 0.01, now it become 1 molar. And that of copper sulfate is 0.0. Initially 0.1, now become 0.01. The EMF is changed into E2. EMF is changed into E2. What is the relationship between E1 and E2? Okay, let's go. So question given, here we have two situations, right? The initial situation, I'm calling it electrode potential, the cell potential given to be E1. In the initial case, that cell potential given to be E1, okay, fine. Cell potential given to be E1. In second case, cell potential given to be E2. The cell question is ready. It's a previous need question too. You may know this one, right? Zn bar, ZnSO4. You can see same in our Excel course need worksheet, right? In Zn bar, I think question number 12 or 13, you can check, 12 or 13 I guess. Zn bar, ZnSO4, 0.01 molar. So initially the concentration of ZnSO4 was, Zn2 plus ion was 0.01 molar. Copper sulfate was 0.1 molar, okay. It's having a potential of E1, having a cell potential of E1, okay, cool, right? But question given, and the EMF changes into E2 when the concentration of ZnSO4 is 1 molar and that of copper sulfate is 4. Let's try. Anyway, it's called Nernst equation. Apply the Nernst equation form, right? As you know, Nernst equation will be given by the formula. Nernst equation is E cell equal to, as per the Nernst equation, cell potential called E cell will be given by the formula E0 cell minus 0.059 by N, because temperature given to be 298. So yes, sure, 0.059 by N, 0.059 by N, 0.059 by N, log concentration of product by concentration of reactant, right? Log concentration of product by concentration of reactant. Okay, cool. In case of Daniel cell, as you know, the overall cell reaction for a Daniel cell is Zn plus Cu2 plus giving Zn plus Cu2 plus giving Zn2 plus Cu. Okay, cool. I think you know, right? I already covered, right? A Daniel cell overall cell reaction is Zn plus Cu2 plus giving Zn2 plus Cu. Cool, fine. Apply Nernst equation both situation, please. Apply the Nernst equation both situation. So as per the Nernst equation, I'm calling the first case as E1. So keep it E1, cool, right? Okay, same E1. I'm calling the first case as E1. So E1 equal to, what about E0 cell? Nothing mentioned. So keep it E0, fine, cool, right? Nothing mentioned about E0 cell, fine. Keep it E0 cell. Minus 0.059 by n. N is that number of electron cancelling in my Daniell cell. That number of electron, it's 2, right? N is the number of electrons involved, which is actually 2, right? N is the number of electron which we are cancelling over, or you can say N is same as change in state, right? N is same as change in state also. For example, in this reaction, you may know these things. Like, I am teaching for those people who are going to try 2025 Cbse board. So I hope you know things, right? So take in that sense, okay. My lecture will be in that cell, because I'm going to teach you those who are going to try 2024 nearby next month. So you know something regarding zinc. State of zinc is 0. Yes, state of zinc is 2 plus. So 0 to 2 means change is 2. 0 to 2 means change is 2. Same as that electron cancelling 2. Log concentration of Zn2 plus, right? Log concentration, I'll add one more step, okay. Concentration of Zn2 plus divided by concentration of Cu2 plus. So E1 equal to E0 cell minus 0.059 by 2. 0.059 by 2 log, in the first case, I think the concentration of Zn2 plus same as 10 raised to minus 1, right? In first case, the concentration given to be 0.01, same as 10 raised to minus 2, right? First case, concentration of Zn2 plus given to be 0.01, same as 10 raised to minus 2, divided by concentration of Cu2 plus 0.1, cool, 10 raised to minus 1, right? 0.1 same as 10 raised to minus 1. So put over here, please. We'll be getting like E1 equal to E0 cell minus 0.059 by 2 log of 10 raised to minus 2 by 10 raised to minus 1 will be 10 raised to minus 1, right? 10 raised to minus 1 means minus 1 will come in front. So minus 1 log 10 is 1. So it's minus. Minus will become plus, right? 10 raised to minus 1 means minus 1 will be coming in front. So minus 1 into log 10 is 1. So it's minus 1. Minus will become plus. So I can say E1 equal to E0 cell plus 0.059 by 2. Keep it over there, wait, okay. Just keep it over there, wait. Now do the same for, by 2, right? Do the same for that E2 part. Apply same logic for E2. Same logic for E2, right? So I can say second situation. In the second situation, I'm calling it as E2, okay. In the second situation, I'm calling it as E2, okay. So I can say E2 equal to, I'll do the same for E2 then. So that's the same ditto for E2, right? I'm calling it as E2. Second case, I'm calling E2. Remaining all same, there is a difference in the potential of, the concentration of zinc, remaining all same, cool, right? So E2 equal to E0 cell minus 0.059, any same, right? Change in state is same only, the electron is same only. Log concentration of Zn2 plus by Cu2 plus, okay. Log concentration of Zn2 plus by Cu2 plus, okay. Here the problem is, here given that concentration of ZnSO4 initially was 0.01, changes into 1. So now the concentration of Zn2 plus is 1, cool, right? 1 divided by concentration of Cu2 plus. Before case, the concentration was 10 raised to minus 1. Now it become 0.0, 10 raised to minus 2, right? The previous, in the E1 case, concentration was 10 raised to minus 1. Concentration was 10 raised to minus 1. Now it becomes what? 10 raised to 0.01 means 10 raised to minus 2, right? 10 raised to minus 2, okay. So it is 10 raised to minus 2. 10 raised to, in the initial case, it was, do one thing, guys. Instead 0.1, you can make into 1, make it 0.1, okay. Instead 1 molar over there in this worksheet, okay. You can do like instead 0.1, make into, instead 1, please make into 0.1 more. Then only you will get the correct option, I guess. Maybe printing mistake. Make into that 1 molar into 0.1. Now it's perfect, I guess. So once again, you do the same for E2. Do same for E2. So E2 will be given by E0 cell minus 0.059 by 2 log concentration of Zn2 plus by Cu2 plus cool. In the first case, it was 0.01, now it becomes 0.1. 0.1 means 10 raised to minus 1. 0.1 means 10 raised to minus 1. In the first case, regarding the E1 case, it was 0.01, making 2. Now it become 0.1 molar, same as 10 raised to minus 1. Same as 10 raised to minus 1. Divided by concentration of Cu2 plus. In the first case, it was 0.1, now it becomes 0.01, right? In the first case, it was 0.1, now making 2. 0.01 means same as 10 raised to minus 2. Same as 10 raised to minus 2. So, getting like E2 equal to E0 cell minus 0.059 by 2, cool, 0.059 by 2 log 10 raised to minus 1 by 10 raised to minus 2 will be 10 raised to 1, right? That means 10, okay. 10 raised to minus 1 by 10 raised to minus 2 will become 10 raised to 1, I mean 10, log 10 is 1, right? So, getting like E2 equal to E0 cell minus 0.059 by 2, okay. But E1 was what? 0.059, I mean E1 was E0 cell plus 0.059 by 2, right? I'm just copying the value of E2 from there, right? E2 we got like E2 was E0 cell minus, E1 was E0 cell plus something, okay, but E2 was E0 cell minus, just copying from there, back over here, E2 equal to E0 cell minus 0.059 by 2, right? What we can say? So one is E0 cell plus something, next one is E0 cell minus, so that means you can say E1 is greater than E2, right? E1 is greater than E2 means go with your option B, please, because I know E1 is E0 cell plus something, right? But E2 is E0 cell minus. Obviously, E1 is having bigger value because plus something, right? So E1 will be greater than E2, option B, okay? Cool. Going for the next one. Delta G and E0 cell for a spontaneous reaction will be, okay? Delta G and E0 cell for a spontaneous reaction. See guys, as you know, delta G and E0 cell will be connected by the formula delta G is equal to, delta G is equal to minus NF E cell, or delta G naught is minus NF E0 cell, fine. So I can say, as you know from the grade level thermodynamics concept, a process will become spontaneous if delta G is negative, right? A process, as you know, I guess, like grade 11 thermo concept, a process will become spontaneous, okay? A process will become spontaneous if the value of delta G should be negative, right? A process will become spontaneous if the value of delta G is negative. But in the formula, delta G is equal to minus NF E cell, or whatever means. If standard one, delta G naught is minus NF E0 cell. N is always a positive quantity, like number of electron, right? F is a constant, always a positive value of 96500, but E cell may be positive or negative. But to become delta G negative, E cell should be positive. Then only I can say delta G will become negative or a process will become spontaneous. Basic formula, delta G is minus NF E cell. Okay, fine, cool, right? And I know as for the grade 11 thermo concept, a process will become spontaneous if delta G is negative. To become delta G negative, N is always a positive quantity, F is always a positive quantity, E cell may be positive or negative, but to become spontaneous, to become delta G well negative, E cell should be positive. So E cell positive, delta G negative, so I can say delta G value should be negative, E cell should be positive, means negative and positive, option C, right? Delta G value should be negative and del E cell should be positive. Go with option C, please. Okay. Question number 7. It's a good one, right? It's a cliche one actually. The same thing may come in like give the reason question or give account for the following. Same, or may come like assertion reason. Before entering this one, you may know, I guess, what is meant by conductivity, guys? Conductivity is the conductance per unit volume, right? As per the definition, what is meant by conductivity means conductivity is the conductance per unit volume. What is meant by conductivity means it is the conductance per unit volume. It is the conductance per unit volume. Conductance per unit volume. Imagine you have two solutions, okay? For easy understanding only, I'll give you one shortcut. I mean, you know these things, right? Suppose you have a two solution. I'm calling one as concentrated one and one as diluted one, okay? One as concentrated solution and a dilute solution. See guys, suppose we have a concentrated solution, okay, fine, cool. I'm diluting by adding water. Obviously, on adding water, dilution happens, space will be more, so it will be spread over there, will be spread over there. Definitely having some electrolyte, okay, definitely having some electrolyte, right? My topic is actually, I'm going to be dealing with what is meant by conductivity. Conductivity is the conductance offered per unit volume. By definition, what is meant by conductivity means conductivity is the conductance per unit volume. Okay, conductance per unit volume. Imagine you have two solutions. I'm calling a concentrated one and a diluted one. Who will be having more conductivity? Give a second, think. Who will be more? Who will be having more conductivity? The concentrated one or diluted one? As you know, conductivity means what, guys? It's a conductance per unit volume, right? So if you take a unit volume in case of concentrated solution, if you take a unit volume in case of concentrated solution, more number of ions, but on diluting, spreading happening. On spreading, I can say take a unit volume over here, less number of ion. What is meant by conduction? Movement of ion. The word meaning of electricity means motion, flow, right? So here contain more number of ion, so more conduction. I mean, here unit volume containing, here you can see unit volume containing more number, but here contain less number of ions. So obviously, on dilution, number of ions per unit volume is decreasing. Number of ion decreasing means same as conductivity, because by definition, conductivity is the conductance per unit volume. It's a conductance offered per unit volume in case of a concentrated one and diluted one. Obviously, on adding, space will be increasing. Okay, cool, fine, right? So here I can say, here in a unit volume, in a 1 meter cube volume, in a 1 centimeter cube volume containing more ions, but here contain less number of ions. And I know the word meaning of current means motion, flow of electrons, flow of ion, whatever may be. Here you can see more number of ions in unit volume, so we'll be having more conductivity, because conductivity is the conductance experience in a unit volume. Here unit volume containing more number of ion, but unfortunately diluting in a unit volume number of ions are less, or I can conclude that on dilution conductivity decreases, because conductivity is the conductance per unit volume. On dilution, number of ions in a unit volume is less, or conductivity will be less. Cool, right? So assertion, conductivity, oh, again it is a decrease. Okay, let's see. Question, conductivity of an electrolyte increases with the decrease in concentration. See guys, decrease in concentration means same as what? Increase in dilution. Inversely, right? Means on diluting, concentration will be less. So I can say conductivity of an electrolyte increases with the decrease in concentration. See, decrease in concentration means same as increase in dilution. So we can say conductivity of an electrolyte increases with the decrease in concentration, same as increase in dilution. It's wrong statement, because I know on dilution conductivity is decreasing, but here again conductivity increasing is a wrong choice, so assertion will be wrong, because that decrease in concentration same as increase in dilution. So actually conductivity increases with the decrease in concentration means increase in dilution is a wrong choice, because on diluting conductivity is decreasing. Clear? And one more thing, reason given that number of ions per unit volume decreases on, that's okay, fine, because on dilution number of ions, that's why conductivity, but here given conductivity increasing choice. Actually on dilution, reason is okay, cool, right? Because number of ions per unit volume is decreasing, that's why guys conductivity decreasing. So conductivity increasing is a wrong choice, but number of ions per unit volume is decreasing on dilution is a correct fact. So assertion wrong, reason true. Clear? Going for next one. Question given, it's a pakka, numerical side, right? Question, resistance of a conductivity cell filled with 0.1 mole per liter, filled with 0.1 mole per liter of KCl solution, 0.1 mole per liter of KCl solution, 0.1 mole per liter of KCl solution. Resistance means R, right? Resistance means R of a 0.1 mole per liter KCl solution is 100 ohm. Okay, okay. If the resistance of the same cell, that's an important point, resistance of the same cell, okay, resistance of the same cell filled with 0.02 molar, mole per liter, or same, molar, mole per liter, same, right? Resistance of the same cell filled with resistance of the same cell filled with 0.02 molar KCl solution is, okay, 0.02 molar KCl solution is 520 ohm, 520 ohm. Calculate the conductivity. Conductivity means K. Calculate the conductivity means K, and molar conductivity means lambda m of whom 0.02 molar KCl solution. The conductivity of, that means K, right? Conductivity of 0.1 mole KCl solution given to be 1.29 into 10 raised to minus 2 Siemens centimeter inverse. Okay, so conductivity means K. Okay, conductivity means K of 0.1 mole per liter, molar, same KCl solution given to be 1.29 into 10 raised to minus 2 unities Siemens. In effect, I can say we have two solutions, right? I'm concluding my point. Here we have two solutions. One is 0.1 mole per liter KCl and one is called 0.02 molar. It's okay, fine. And I've given that for 0.1 mole per liter KCl solution, resistance given to be 100 ohm. For 0.02 molar KCl resistance given to be 520 ohm. Okay, and we have to find what we required is conductivity called K. Molar conductivity means lambda m of 0.02 molar KCl solution. And one more thing, they given that conductivity K of 0.1 mole per liter KCl solution is 1.29 into 10 raised to minus 2. Okay, continue anyway. The basic formula regarding this all stuff is, resistance R is equal to what? Rho L by M. The key point is, if the resistance of the same cell, I mean both solutions are in same beaker means same length, same area. I mean same cell constant, right? Because length by area is called cell constant, right? So the key point is that the twist is that the resistance of the same cell means same beaker, same length, same area, length by area, or same cell constant given to be points, okay, blah blah, right? Anyway, question ready. Conductivity and molar conductivity of this one, right? Go ahead. I know resistance R is given by the formula. Resistance R is given by the formula rho L by A. So resistivity rho is equal to cross multiply, rho is equal to Ra by L. Resistivity rho equal to Ra by L. What I required is K, same as 1 by rho. So R equal rho L by A, rho equal to Ra by L. Reciprocal. Reciprocal means 1 by rho. Reciprocal means 1 by rho. 1 by rho equal to, take over here also, L by Ra, L by Ra. That 1 by rho is called what? K. That 1 by rho called K. So K is equal to what? L by Ra. K is equal to L by Ra. But unfortunately, length is not given here. Area is, but only R is getting ready. Okay, fine. We've done the formula over there, right? K is equal to, formula ready. K is equal to L by Ra. Okay, cool, right? K is equal to L by Ra. K is equal to L by Ra. What we require is K. First of all, then think about lambda. Wait, let's think about K first. K is equal to L by Ra. So K is equal to L by Ra. How much is L? How much is A? No idea. Okay, keep it over there. Wait, fine. Keep that L by A over there. Keep that L by A over there. Remaining all is fine, cool, right? Remaining resistance we know, right? Resistance we know that L by A, keep it L by A, fine, okay? Keep it L by A, fine. But resistance given to be how much, guys? 520, right? That means if you know the value of length and area, problem is solved. If you know the value of length and area, problem is solved. But unfortunately, length and area is not what we'll do. They given that both solutions are in same cell, same beaker, same length. And so do the same for the first part. Do the same logic for, take the equation again, K is equal to, take the equation again over here. I'm just copying it, okay? Apply same equation in the first case, okay? So K is equal to L by Ra, K is equal to L by Ra. So from here I can say length by area, same as what? K into R. Here K given, R given, so we'll get length by area. This length by area and this solution length by area will be same because both of them are in same cell, Since both of them are in same, so I can say length by area of the 0.1 mole per liter KCl will be same as 0.02, right? So do one thing, find out the L by A from here, okay? So I can say Kc equal to L by R, cool, fine. From I can say L by A is equal to K into R into R. Here we know K is how much? 1. Okay, 1.29 into 10 raised to minus 2. Resistance is 100. 100 and 10 raised to minus 2 get cancelled. L by A will be 1.29. What are the unit of L by A? Length is in centimeter. Area will be centimeter square. So centimeter by centimeter square means minus 1, right? Unit of length is centimeter. Area will be centimeter square. So centimeter by centimeter square will be centimeter raised to minus 1. Cool, put over there. Come, that L by A, put over here. So 1 by 520 into by 520 into L by A, so that L by A is 1.29. I know I'm moving fast, but I'm dealing this session for those who are going to try 2025. So you know this topic, right? So taking that sense, K is equal to 1 by 520 into 1.29. From solving, you will get the value of K. It's fine, right? Unit of K is Siemens centimeter inverse. On solving this, we'll get the value of K, cool. And the unit of K will be, so value of K will be 1.29 divided by 520. On solving this, we'll get the value of K. The unit of K will be Siemens centimeters. Unit of K will be, same this one guys, Siemens centimeter inverse, right? From the value of K, you can find out lambda m, molar conductivity. The K is ready, 1.29 by 520, it's okay, right? From the value of K, we can find out lambda m called molar conductivity by using the formula 1000 into K divided by M. From this value of K, we can find out the molar conductivity M by using the formula 1000 into K by M, where K is called as conductivity. Just copy from there. Conductivity, copy from there, that's 1.29 by 520. 1.29 by 520. M is molarity for the second case. Molarity given to be 0.02. On solving, answer ready. On solving, answer will be ready. So if we know the value of K, we can find out the molar conductivity lambda m by dumping the formula 1000 into K by M, where K is called as conductivity. Copy from there, 1.9 by 520, and molarity M given to be 0.02, right? Solving, get the value. Unit of lambda m is Siemens centimeter square mole inverse, okay? Obtain the unit of lambda m will be Siemens centimeter square mole inverse. Cool, right? Question number 8 now. Going, 9th one. Before entering that one, let's have a graph, okay? I'm going to plot a graph right now, okay? The graph is going to be plotted between lambda m and root c, okay? I'm going to plot a graph right now. The graph is going to be plotted between lambda m and root c, where lambda m is called molar conductivity, c is called as concentration, okay? My aim is to plot a graph, cool. The graph is coming between lambda m and root c. Lambda m is called molar conductivity. Root c is called concentration, right? Anyway, the graph was plotted initially for strong, then for weak, but fine, we can do for the same graph for strong and weak electrolyte. For strong electrolyte, the graph of like a straight line, okay? For strong electrolyte, the value, I mean the graph of lambda m versus root c was a straight line, cool. But for a weak electrolyte, the graph obtained was like a curve, like a parabola. It was a weak, for weak, right? Before analyzing the graph and all, here the graph is very fine, okay? The graph is plotted between lambda m and root c, okay? The graph is coming between lambda m and root c. Lambda m is called molar conductivity, root c is called as concentration. As we move from here to here, molar conductivity increases. As we move from here to here, molar conductivity decreases. As we move from here to here, concentration increases or dilution decreases, because concentration will be inversely proportional dilution, right? So as we move from here to here, concentration is increasing means same as dilution is decreasing. Or I can say, as we move from here to here, concentration is decreasing or dilution is increasing, okay? Okay, cool, right? So my aim is to plot a graph. The graph is plotted between lambda m and root c. Lambda m is called molar conductivity. Root c is called as concentration. As we move from here to here, molar conductivity increases. As we move from here to here, molar conductivity decreases. As we move from here to here, concentration increases or dilution decreases. As we move from here to here, concentration decreases or dilution increases. Let's say the graph for strong electrolyte first, okay? Let's analyze the graph of strong electrolyte first. On analyzing the graph, I can say, if you are coming from here to here in my graph, I mean the graph of lambda m versus root c for a strong, as we move from here to here, concentration is decreasing, dilution is increasing, graph is moving up, means I can say molar conductivity is decreasing. As we move from here to here, concentration decreases, dilution increases, but graph is moving up, means we can say molar conductivity is increasing. Okay, fine. Let's do the analysis for the strong also, okay? For the weak, right? For strong, we concluded that graph is getting a straight line. Graph is plotted between lambda m and root c, okay? As we analyze the graph, as I move from here to here, concentration is decreasing, dilution is increasing. Since graph is moving up, means I can say molar conductivity is increasing, okay? Do the same for weak also, the same for weak electrolyte, okay? The strong, the graph of lambda m versus root c was a parabola, In this parabola, do the same analysis, same thing, okay? Taking 3 points over here, okay, cool, right? As we move from here to here, obviously I can say concentration is decreasing, dilution is increasing, graph is moving up, means I can say molar conductivity is increasing. Problem is, for strong as well as weak, as we move from here to here, concentration is decreasing, dilution is increasing, graph is moving up, means molar conductivity is increasing, okay, but that increase is a gradual, that increase is a slow, steady increase for strong, but a sudden, a striking increase for weak. Why? For strong as well as weak, as we move from here to here, concentration is decreasing, dilution is increasing, graph is moving up, means I'm sure molar conductivity is increasing, or that increase is a gradual increase, that increase is slow increase for strong, but a sudden increase for weak. Why? In case of strong, if you're adding what, diluting, right? If you're diluting, space is increasing. When space is increasing, more motion, so more conduction, so conductivity, molar conductivity will be increasing, okay? See guys, strong as well as weak, as we move from here to here, concentration decreasing, dilution increasing, graph is moving up, means molar conductivity is increasing, okay, but that increase is a gradual increase. That increase is a slow increase for strong, but a sudden increase for weak, because in case of strong, on diluting, on adding water, space is increasing, mobility is increasing, motion is more, so molar conductivity will be fine. But in case of weak, I think I'm sure on adding water, space will be increasing, mobility will be more. But in addition to that, strong means they get completely themselves get dissociate into ion, but weak, they cannot get completely ionized. Strong electrolytes are electrolyte, they will get completely ionized, but weak means they are partially ionized. They cannot themselves get completely ionized. But on adding water, you can say more ions will be increasing. Why ions are not increasing strong? Because in strong, they already get completely ionized. They themselves get completely ionized. But in case of weak, on adding water, not only space, not only mobility, I can say number of ions are also increasing. Because weak, they themselves cannot get completely dissociated into ions. But for strong, on adding water, I can say, in case of strong, I can say, on adding water is only scope of increasing mobility, because ions, they themselves get completely already ionized. But in case of weak, not only mobility, not only space, on adding water, number of ions are also increasing, because they themselves cannot get completely ionized. Weak means completely ionized. In case of strong, for dilute cell, already ions are 100 almost, I can say almost ions happen. On water, space is increasing, only mobility increasing, but it's happened to ion. But weak, they themselves cannot get completely ionized into complete ionized, right? On adding water, because of that space of water, I can say mobility. In addition to mobility, ions are also generating, increasing, right? but ions are not increasing for strong. They themselves get already completely ionized. So I can say that increase is a gradual for strong, because in case of strong only mobility is increasing, ions are already get completely increased. But in case of weak, not only space, not only mobility, ions are also increasing. So I can say that increasing molar conductivity will be a sudden striking effect, right? So come to my option. So I can say question number 9th one right now. Question ready. Which of the following represent the variation of molar conductivity called lambda m, molar conductivity called lambda m versus concentration, right? Conductivity for strong and weak. For A, it's a steady increase. It's a gradual increase because it's a strong, right? For strong, on dilution, only mobility is nothing happened to ions. Ions are get already completely dissociated. But in case of B is, you can say in case of B, the graph is a parabola, graph is a curve. That means there is a sudden increase in molar conductivity because both ions and mobilities are increasing. So probably A will be strong and B will be weak, right? You may get this kind of question. You may know, I guess. Question may come like on for we have two electrolytes A and B. On dilution, lambda m of A increases 25 times, B increases by 1.5 times. Same logic only. 25 times means sudden increase, so it will be a weak. But 1.5 times means it's a gradual, so it will be strong. You may know this. One more same type of question. It may be in the word, right? You may know, I guess. On dilution, lambda m of A increases by 25 times, but lambda m of B increases by 1.5 times. Same logic only. The one having 25 times is a sudden increase, it's a weak, but 1.5 is a gradual one. So A will be strong, B will be weak. Obviously option A, guys. 9th one, A is the right answer. Fine. Going for the 10th one. Before entering into 10th one, you may know, I guess, what is meant by Kohlrausch's law, guys? Kohlrausch's law means, what is meant by Kohlrausch's law means lambda m infinity, or you can say molar conductivity at infinite dilution, same as limiting molar conductivity. What is meant by Kohlrausch's law? As per Kohlrausch's law, lambda m 0, I mean limiting molar conductivity, lambda m 0, I mean limiting molar conductivity of an electrolyte is equal to limiting molar conductivity of electrolyte is equal to lambda m of cation plus lambda m of anion, right? Question may be coming like this. What is meant by Kohlrausch's law? Explains to application to. Usually the board course will be of this category. What is meant by Kohlrausch's law? Explains to application. What is meant by Kohlrausch's law? Lambda m is called as molar conductivity. Lambda m not called as limiting molar conductivity. Okay, as per Kohlrausch's law, limiting molar conductivity of electrolyte is sum of limiting molar conductivity of cation plus anion. Simply speaking, lambda m 0 of electrolyte will be lambda m 0 of cation plus lambda m 0 of anion. Okay, as per Kohlrausch's law, limiting molar conductivity of electrolyte is the sum of limiting molar conductivity of cation plus anion. Fine, I guess. Once again, lambda m 0 of electrolyte will be sum of lambda m 0 of cation plus anion. Application number 1. By using Kohlrausch's law, we can find out the lambda m 0 of weak electrolyte. By using Kohlrausch's law, we can find out the lambda m 0 of weak electrolyte. And one more thing, from Kohlrausch's law, we can find out degree of dissociation called alpha also. By using Kohlrausch's law, we can find out degree of dissociation alpha given by the formula lambda m divided by lambda m naught, where lambda m is called as molar conductivity, lambda m naught is called as limiting molar conductivity. Okay, so conclusion, what is meant by Kohlrausch's law means it's lambda m 0 of electrolyte is equal to lambda m 0 of cation plus lambda m 0 of anion. Same I can say limiting molar conductivity of electrolyte is the sum of limiting molar conductivity of cation plus anion. To application, first one, we can find out the lambda m 0 of weak electrolyte. One more thing, we can find out degree of dissociation alpha. Degree of dissociation alpha will be given by the formula lambda m divided by lambda m naught, where lambda m is called molar conductivity, lambda m naught called limiting molar conductivity. Okay, come back. Question, from the following molar conductivities at infinite dilution, that means molar conductivity at infinite dilution called lambda m naught. Molar conductivity at infinite dilution called lambda m. Calculate the lambda m0 of NH4OH. Question ready, right? From the following molar conductivity at infinite dilution, that is lambda m naught. Calculate the lambda m naught of NH4OH. Calculate the lambda m naught of NH4OH. Given that lambda m naught of NH4Cl equal to NH4Cl is equal to 129.8 Siemens. I mean, I think it should be Siemens, right? My mistake, I guess. It should be Siemens centimeter square mole inverse. My mistake, sorry. Should be Siemens centimeter square mole inverse. Here given is fine, okay. Here also Siemens centimeter square mole inverse. So lambda m0 of NH4Cl given to be 129.8 and lambda m naught of NaOH given to be lambda m naught of NaOH given to be 218.4. 218.4. Similarly, it should be lambda m naught, guys. Should be lambda m naught for NaCl. Lambda m0 of NaCl. Lambda m0 of NaCl given to be 0.8. See, the thing is that because they will give you lambda m naught of 3 and find the lambda naught of unknown one. Because they will give lambda m naught of 3 the 3 electrolyte, find out the lambda of unknown. Here my unknown is NH4. So NH4 create a formula for NH4 by using the given data. Okay? Lambda m0 of N4. So what would do that? Create a formula for NH4 by given data. I can add NH4C and NaOH. Adding NH4 and NaOH from NaOH minus N and Cl called what? NaCl minus Na and Cl called NaCl. So create a formula for NH4OH by using the given three datas. The given three datas are NH4Cl, NaOH, NaCl. Cool. So we can do one thing. Add NH4OH and NH4OH and NaOH. From NH4OH we'll be getting NH4, okay? From NH4OH we'll be getting NH4. From NaOH we'll be getting OH. Remove that NaCl. So put lambda m throughout. So getting like lambda m0 of NH4OH equal to lambda m0 of NH4OH equal to lambda m0 of NH4Cl plus lambda m naught of NaOH minus lambda m naught of NaCl. Okay. How much is lambda m naught of NH4Cl given to be 129.8 plus lambda m naught of NaOH given to be 218.4 and lambda m naught of NaCl given to be 108.9. You will get an answer. Conclude it. Option will be, I mean the unit will be same, Siemens centimeter square mole. Check please, guys. We're getting like unit should be like answer will be 129.8 plus 218.4 minus 108.9. Unit should be same, that Siemens centimeter square mole inverse. Okay. One more same category from Kohlrausch's law. Okay. Question, simple only. Try anyway. Calculate degree of dissociation alpha. So what are required is alpha, right? Calculate the degree of dissociation alpha. So what I need to find out is degree of dissociation called alpha. Which molar conductivity lambda m is given to be, which molar conductivity lambda m given to be 39.05 Siemens centimeter square mole inverse. Given that lambda 0 of H plus equal to, given that lambda m 0 of H plus equal to 349.8 and that of lambda m naught of CH3 COO minus equal to 40.9. Okay, just the formula. What I required is degree of dissociation alpha. What I need to find out is degree of dissociation alpha. Given that if it's molar conductivity called lambda m given to be 39.05, given that lambda 0 of H plus is 349.8 and that of CH3 Siemens is 40.9, right? So we'll get like degree, as you know, the formula for degree of dissociation alpha will be alpha equal to lambda m divided by lambda m naught. Degree of dissociation alpha equal to lambda m divided by lambda m naught. Lambda I am called molar conductivity. Lambda I am called molar conductivity given to be 39.05. Divided by lambda I am not sum to value, right? For the lambda I am not of acetic acid, sum these two value, right? On getting the getting the value of lambda I am not of acetic acid called CH3COH. Use Kohlrausch's law, sum of cation plus anion, right? So lambda I am 0 of CH3COH will be lambda I am 0 of CH3COO minus plus lambda I am 0 of H plus. Cool. For CH3CO minus given to be 40.9. That of H plus given to be how much? H plus given to be 349.8. Summing, getting an answer over here, dump over here, ready. So degree, there is no even for alpha because get cancelled, right? Lambda and lambda get cancelled. So no even for alpha. Anyway, alpha will be given by the formula lambda m by lambda m naught. Lambda m is directly given to be 39.05. Cool. And from that, to get the lambda m naught, use Kohlrausch's law, sum of cation plus anion. Cation and anion given to be 349.8 and 40.9. Getting an answer. Put answer over here. So you will get lambda m naught dividing, you will get alpha. Cool. Okay. See, I know I'm doing in a way that those who know this chapter. Okay. That's it. Go for next question. Okay. So 12th one right now. When a steady current of 2 ampere was passed through two electrolytic cells A and B containing electrolytes. Before that, I'll give you one thing. Okay, let's focus one thing before that. What is meant by Faraday's law, please, guys? What is meant by Faraday's law? As per Faraday's law, I can say Faraday's law means if Faraday's first law and Faraday's second law, right? Let's say about Faraday's first law first. What is meant by Faraday's first law, guys? According to Faraday's first law, we have two laws. Let's see about Faraday's first law first. As per Faraday's first law, according to Faraday's first law, mass of the substance deposited at the electrode is directly proportional to charge, right? Simply speaking, what is meant by Faraday's law means mass of a substance deposited at the electrode will be directly proportional to charge. Simply speaking, I can say M directly proportional to Q. Cool, right? So I'm in Faraday's law right now. What is Faraday's first law means mass of the substance deposited at the electrode will be directly proportional to charge pass M directly proportional to Q. But in the numerical side, we'll be dumping the formula. Mass of the substance deposited is equal to atomic mass into I into T divided by valency into or divided by 96500 into valency divided by 96500 into valency. And my topic is Faraday's law. Faraday's first law or second law. What is meant by Faraday's first law means something. Mass of a substance deposited at the electrode will be directly proportional to charge pass M proportional to Q. Fine. But numerical side, you can use the formula. Deposited mass M is equal to atomic mass into I into T divided by 96500 into valency. Cool. That's Faraday's first law. Let's see about Faraday's second law then, right? According to Faraday's second law, let's see about Faraday's second law. According to Faraday's second law, imagine two electrolytic cells connecting in series. Before that, Faraday's second law, imagine I have two electrolytic cells. Okay, cool. I have two electrolytic cells. I'm connecting these two electrolytic cells. We'll be having anode, cathode. Fine, cool. We'll be having anode and cathode. I'm connecting these two electrolytic cells in series. Okay, connecting these two electrolytic cells in series connection. I know what is the specialty of series connection. In series connection, current passed will be same, right? In series connection, current passed will be same. Anyway, it's Faraday's second law right now. Have two electrolytic cells connected in series. Cool. And I know in series connection, current passed will be same. When current is passing, mass will be depositing, and the deposited mass M will be directly proportional to E. Deposited mass M will be directly proportional to where E is called as equivalent mass. That equivalent mass E will be given by the formula atomic mass divided by valency. That equivalent mass E will be given by the formula atomic mass divided by valency. M directly proportional to E, or I can say M1 by M2 is equal to E1 by E2. M1 divided by M2 is equal to E1 divided by E2. Faraday's second law once again. What is meant by Faraday's second law means connect two electrolytic cells in series. I know, in series connection, current passed will be same. When current is passing, mass will be depositing, and that deposited mass M will be directly proportional to E, where E is called as equivalent mass, and that equivalent mass E will be given by the formula atomic mass by valency. Since M directly proportional to E means I can say M1 by M2 is equal to E1 by E2. Are you okay? That's it. Question number 14 right now. When a steady current of 2 ampere, question, when a steady current of 2 ampere was passed through, when a steady current of 2 ampere was passed through electrolytic cells A and B, passed through electrolytic cell A and B, containing electrolytes, ZnSO4 and CuSO4, containing ZnSO4 and CuSO4, okay, containing ZnSO4 and CuSO4, connected in series, okay, connected in, okay, fine, cool, right, connected in series connection, okay, connected in series, 2 gram of copper, fine, yes, 2 gram of copper were deposited at the cathode of cell B. That's clear. A part of the question. How long did the current flow? How long means time taken. Let's do the A part first. Question ready, right? Question given that when a steady current of 2 ampere was passed through 2 electrolytic cell A and B, okay, fine, A and B, containing electrolytes ZnSO4 and CuSO4, connected in series, fine, series connection. 2 gram of copper were deposited at the cathode of cell B, cool. A part of the question, how long means current time taken, right? How long did the current flow means what we record is time taken. Adam the Faraday's first law formula, right? You know, as per Faraday's first law, mass of the substance deposited at the electrode is equal to atomic mass into I into T divided by valency into, or 96500 into valency divided by 96500 into valency. Cool, right? Here we can use that B part, right? Because whose mass is given, right? Since mass of copper is, use that part, okay? Since mass of copper is given, use that part. I can say mass of the copper is 2, which is equal to atomic mass. In case of copper, atomic mass given to be 63.5, cool. Into I is the current is given to be 2 ampere, right? Current is given to be 2. Time we have to keep it T, there's a time T, keep it T, fine, right? Divided by 96500 into valency divided by 965. Valency is same as charge of metal, cool, right? Valency will be same as charge of metal. In case of copper sulfate, we'll be having Cu2 plus and SO4 2 minus, means I can say charge of metal copper is 2. Solve it. On doing, I can say 2 and 2 get cancelled. Remaining time T is equal to cross multiply 2 into 96500, that 63.5 will come down, cool, right? 2 get cancelled. 2 into 96500, that 63.5 will come down. On solving, you will get the answer. Unit of time will be in second, okay? We'll be getting the answer, time in second. So how long did the current flow means time taken? Dump the formula, Faraday's first law. M is equal to atomic mass into I into T by 96500 into valency. So atomic mass, I mean deposited mass M is given to be 2 gram. Atomic mass of copper is 63.5. Current I is again 2 ampere. Time we have to find out, keep it T. Divided by 96500 into valency. Valency will be 2, right? It's big because here's charge. Valency will be same as charge. 2 and 2 get cancelled. Cross multiply. So it's fine, cool, right? Time will be in second. Go for the second part. What mass of zinc was deposited at the cathode of cell A? The B part of the question. What mass of zinc means we have to find out mass of zinc, right? What mass of zinc was deposited means what I need is mass of zinc deposited at the cathode of cell A. use the Faraday's second law concept. As per Faraday's second law, as you know, as per Faraday's second law, M mass deposited mass M is, as per Faraday's second law, deposited mass M is directly proportional to E. Or I can say M1 by M2 is equal to E1 by E2. You can say that M1 by M2 is equal to E1 by E2. You can take one as zinc and one as copper. Cool. I'm calling zinc as one. Okay, first one, and copper as second one. Cool. You can say M1 means that is first one called zinc. So mass of zinc divided by M2 means second one called copper. So mass of copper. Is equal to E1 means equivalent mass of first one called zinc. Equivalent mass of zinc divided by equivalent mass of copper. What we required is mass of zinc, so keep it same, mass of zinc. What we required is mass of zinc, keep it same, divided. What about mass of copper, guys? Here mass of copper given to be 2 gram from the first part, right? Mass of copper given to be 2, okay? Mass of copper is 2, which is equal to equivalent mass. Equivalent mass is atomic mass by valency. So equivalent mass of zinc means atomic mass of zinc by valency. Equivalent mass of zinc means atomic mass by valency. Atomic mass of zinc given to be 65, right? Atomic mass of zinc given to be 65. Divided by valency. Valency means same as magnitude of charge. Cool, right? In case of metal, in case zinc, say as like copper, same situation. For zinc, we'll be having Zn 2 plus and SO4 2 minus. So I can say charge of metal zinc is 2, right? Charge of metal zinc is 2 divided by equivalent mass of copper. Equivalent mass is again atomic mass by valency. For copper, its atomic mass given to be 63.5, right? For copper, atomic mass given to be 63.5 divided by valency. Second part, what are equal is mass of zinc. For getting mass of zinc, use, why I'm using second law? Because I had given that now connected in series, right? In series connection, as per Faraday's second law, when two electrolytic cells are connected in series, then the mass of the substance deposited at each electrode will be directly proportional to E, where E is called as equivalent mass, right? So M proportional to E means I can say M1 by M2 is E1 by E2. Them over there, right? So it will be coming like mass of zinc by mass of copper given to be 2. Equivalent mass of zinc is atomic mass by valency 65 by 2 for side, right? So 2 and 2 get cancelled. Remaining mass of zinc divided by 2 is equal to 65 divided by 63.5. So I can say mass of zinc, just cross multiply 2 over there. So I can say mass of zinc is equal to 65 divided by 63.5 into 2. Solve, I think 2 points, some check 2 points or something like check over there. That mass of zinc obtained will be in gram, right? That unit of mass will be in gram. Hope you're fine. Almost going to wind up. Last one now. Question number 13. The cell which is used in hearing aid. Cell used in hearing aid. See, I told you in my starting, I told you now, we have 2 types of cell called primary cell and secondary cell. Non-rechargeable one is primary, rechargeable one is secondary. Examples of primary cells are dry cell, mercury cell. Example of secondary cell are lead storage cell and nickel cadmium, whereas fuel cell is neither primary nor secondary. They will ask either anodic or cathodic of any these 5, damn sure. Go through that, okay. Anyway, here given cell used in hearing aid. See, you know, cell used in transistor is dry cell. Used in hearing aids and watches is mercury cell. Used in mobiles and inverters, or you can say inverters and automobile, it is called actually, automobiles and inverter will be lead storage cell or lead storage cell, right? So I can say the cell used in transistor will be the cell used in transistor is cell used in transistor will be dry cell. Cell used in transistor will be dry cell. Cell used in mercury cell. Cell used in mercury cell is, the cell which is used in watches and hearing aid, right? That's better, right? Cell used in watches and hearing aids. Cell used in watches and hearing aid will be mercury cell. Whereas cell used in automobiles and inverters, okay. Cell used in automobiles or inverters. Cell used in automobile and inverter is lead storage cell. Used in automobiles and inverter is lead storage. And Apollo space program is fuel cell, right? Apollo space program, one which is used in Apollo space program is fuel cell. Used is fuel cell, right? Concluding, so used in transistor will be dry cell. The one which is used in watches and hearing aid will be mercury cell. Automobiles and inverters will be lead storage cell. Finally, Apollo space program is fuel cell. Fuel cell is neither primary nor secondary. You may know, I guess, right? So 13th one, the cell which is used in hearing aid. Hearing aid is mercury cell, option B, right? Cell used in hearing aid will be mercury cell. The last one. 14th one. Using E0 values of A and B, predict which is better for coating the surface of iron whose potential given to be minus 0.44 to prevent corrosion. See guys, for preventing corrosion of iron, iron will be coated with a more reactive metal. The one which is more reactive means even the given option having less electrode potential. Electrode potential less means more reactive. Question given that using E0 values of A and B, predict which is better for coating the surface of iron. If you want to protect iron from corrosion, you can coat iron with more reactive metal. More reactive means less electrode potential, because electrode potential reactivity is inversely proportional. Am I given choices? A and B. A is having an electrode potential of 2.37, whereas B is having electrode potential of minus 0.14. While comparing minus 2.37 and minus 0.14, minus 2.37 is lower value. If electrode potential is less, reactivity will be more, and more reactive metal is better for coating. Example, zinc. Galvanization, sacrifice potential, right? We are sacrificing zinc for copper, right? So what is meant by how to prevent corrosion means coating a more reactive metal, like iron coating zinc, because zinc is more reactive. Why zinc is more reactive than iron? Because zinc is having lower electrode potential. So here question clear only. To prevent corrosion of iron, iron will be coating with A or B. Obviously it will be A, because A is more reactive. Why A is more reactive? Because A is having less electrode potential. Hope you enjoyed my session, I guess. Anyway, I'm dealing this session for those who are writing exam by next month, 2025 February, right? So I'm taking that sense. It's not a regular lecture. It's not like a regular lecture way. I know, but I'm just doing like a capsule one. I think those who are writing exam will get something from here, right? Enjoy. Thank you. Bye. All the best for exam 2.